Hello all. Today we will be seeing how we can implement artificial neural network from scratch by using Keras. Till now, in my deep learning playlist, we have discussed everything theoretical explanation about what are the important parameters inside deep learning artificial neural networks like weights, bias, and we also saw that how back propagation happens, how weight gets updated, what is the initialization techniques of the weights. Now many people were asking when we will be starting the practical application. Today is the class we are going to start, and we'll be focusing on implementing everything from scratch in a wonderful way. Unless until you have understood the theoretical concepts, it will be very easy for you to understand everything. So to begin with, first of all, I need to introduce you to the Keras library documentation. Everything, it's just like an Oxford dictionary, Oxford dictionary for implementing your deep learning models. And any queries that you basically have, you should come over here, you should try to see over here, because every information is given in this particular documentation itself. And as I go along with the videos, I'll be showing you how you can find out simple details whenever you're using any inbuilt functions. This Keras library is basically a wrapper on the top of TensorFlow or Theano. Okay, you can basically use a Theano, CNTK, and TensorFlow. These all are open source libraries, which is very good for creating your neural networks. TensorFlow is basically open. Basically, it is a library that is provided by Google. Uh, so let us just go ahead and first of all try to understand how to install Keras. So in order to install Keras, all you have to do is that go into Google and write conda install Keras. So as soon as you write the first link that you will be getting over here, just click this, just go over here below, just copy this whole command and just go to your Anaconda prompt and paste it over there, right? Go to your Anaconda prompt and paste it over there. So I'll just go over here and paste it over there, okay? Here it is, I'm going to paste it. It'll take some time to install. This Forge, what it makes is that all the other libraries that are dependent on Keras will automatically get downloaded. So after the downloading is completed, you have to wait. It'll take around 10 to 15 minutes for the downloading to happen. Once it is done, now we'll focus on creating a wonderful application, which is like a churn modeling data set for a bank customer. We'll try to create a model with respect to that particular data set by using artificial neural network. Let us go back and let me show you the data set, how it looks like. So this is my code. First of all, my data set name is churn_modeling.csv. This particular data set, you can download it from Kaggle. Apart from that, I'll also give you this particular data set in my GitHub link. So let me just read this. I hope everybody is familiar with how to read it. So this is my data set. I'm just going to show it to you. My data set basically has 13 features. Okay. My dependent feature is the exited column, and you have all the other features like geography, gender, age, tenure, balance, number of product, as credit card. In this, the dependent feature is your exited. So the main thing about this particular data set is we need to predict customers in the bank who will be exiting in the future or not, whether they will exit the bank in the future or not. Because now this churn modeling can play an important role for the bank people, right? Because bank do not want to leave its customer like that, right? And if it is able to predict whether the customer will be leaving the bank in the future, it can provide some better product so that the customer stays in the bank itself, right? So just to bring some loyalty factor. So in this particular data set, you will be seeing that first of all, we'll see what are my independent features. So I'll be considering all the features from credit score till the estimated salary as my independent features. I will not be requiring features like row number, customer ID, and surname, because these are just unique numbers. And surname, it is not related to surname. So this won't play a very big factor. Okay. Then my dependent feature is basically my exited column. In this particular exited column, I'll be taking out my dependent feature. So I'll be using ilock, and I'll be creating my independent and dependent features. Let me just execute it. It has been created. Here is my X data set, and here is my Y data set. Now remember guys, in my data set, you have seen features like geography and gender. These features are basically category features, right? We need to convert this into dummy features. And for my previous videos also, I'll be using get_dummies to create the dummy variable. So I'll execute it. All my dummy variables gets created. It's stored in this particular gender and geography data frame. Okay. Now what I'm going to do, I'm going to concatenate this with my X data set. Okay. Because X is all my independent features. And for concatenating, I'll be using pd.concat and X geography and gender X is equal to 1. So I'll just execute it. So X, everything is getting concatenated. You can go at the end and you can see that 3 features has been concatenated. After that, what we are going to do is that we are going to drop the geography and gender column, which was my original category columns, because I have converted that into dummy variables, right? So I'm going to drop it. For dropping it, I'll basically use x.drop. My column name is geography and gender. So let me just drop. These are dropping unnecessary columns. And then finally, I'm doing a train test split. I hope everybody is familiar how to do a train test split by using sklearn.model selection. You're using the library called as train test split. Once you apply this, you'll be able to do the train test split. And here, I'm basically giving the test size as 20%. Okay, so this is your X train. Is basically having 8,000 records. The total number of records are 10,000, guys. So you'll be able to implement it very nicely. Now, the next thing is that whether do we require feature scaling? I've also asked this question in one of my previous video where I just randomly put some deep learning videos, right? At that time I had asked whether you require feature scaling in standard scalar or not, feature scaling in deep learning or not. So the answer is obviously will require feature scaling. Why? I'll tell you. As you know, if I create a deep neural network from my theoretical classes, right? Suppose this is my input layer, this is my hidden layer, and finally I have my output layer. Remember, this is my feature x1, x2, and x3, right? And as we know that it is connected to all the hidden neurons, right? It's connected to all the hidden neurons, and here you initialize weights. Now always remember, the first step is that this inputs gets multiplied with the weights, right? So I can write it as summation of I is equal to 1 to n w of I x of I, right? Plus the bias, right? Bias will be added over here, b1 and b2. Now remember, this particular step is also very important. How much time it is taking? Now suppose if my magnitude of x1, x2, x3 is completely different, it is a very high number. So this multiplication usually takes time. So what we should do is that we should try to scale down all these features in the same scale range, okay, in the same scale range. Once we do this, what will happen is that the multiplication will happen quickly, and when the back propagation is also done, the derivative of the weights can be easily found out for a smaller numbers. So because of this, what will happen? The gradient descent curve, right? The convergence will happen quickly. The global minima point we will be able to find out very quickly. So let us just go and and these all things we have basically discussed in the deep learning playlist theoretical class also, and in my previous videos also. So what I'm doing is that I'll basically use feature scaling. For that, I'm going to import a library called a standard scalar, and then I'm doing fit transform on my train and transform on my test. So I'll just execute this. As soon as I execute this, you can see my x test and x train has become floating data, and all will be in the same scale. If I just go and execute my X train, you can see that it will be in the same scale. Underscore train. Here, these are just arrays of numbers, and it will be basically be in the same scale. Now, the main thing is that let's start making the ANN. So for creating the artificial neural network, guys, there are some very good libraries required. The library that I'm basically using is Keras. In Keras, first of all, you need to import the models. So every model, every neural network that you create, whether it is in ANN, whether it is in convolutional neural network, whether it is in recurrent neural network, you have to basically import this sequential library. Sequential library is responsible in creating this kind of neural networks, right? Then after that, any hidden layers that you need to create, at that time, you will basically be using this dense library. And for that, you'll be importing from keras.layers. And then you can also import different kind of layers like Riki Relu, which is basically an activation function, and other type of Relu functions. Not important this particular statement right now, but later in the upcoming sessions, I'll be discussing about them more. And if you want to also import a dropout layer, you can do that. You know that what is dropout used for. Dropout is basically your regularization parameter, and you'll be using them more frequently whenever your neural networks are quite deep. But first, to begin with, what I'm going to do is that I'm going to import all these particular libraries. After my import takes place, you can see the message saying that using TensorFlow as the backend, because that is how my libraries got installed. And then first I'll initialize my sequential library. So here it is. This will be an empty, empty neural network currently. We don't know that how many hidden layers will be present and how many neurons are present over there. And then I write classifier.add. And now I'll be using the dense layer to create my first hidden layer. In this, my first parameter will be my output dimension. So output dimension is basically, I'm saying that in my first hidden layer, I'm going to consider 6 hidden neurons. And this is basically initialization parameter. This basically indicates that how your weights needs to be initialized. So here, always remember guys, ReLU activation, whenever you're using a ReLU activation function, in my theoretical classes in deep learning, I told you that whenever we are using ReLU activation function, the initialization, weight initialization called as he uniform and he normal works well. So in this case, I'm basically taking he uniform, and the last parameter that I'm providing is input dimension. But remember guys, this is with respect to Keras 1.0, okay? Now Keras API has also got updated. Let me just execute this. You can see as soon as I executed this, I got some warnings, right? So warning basically says that now your output dimensions, right? Output dimensions has been converted into something called as units. So I'm going to put units over here, right? Similarly, my initializer is basically converted, the keyword is basically converted into kernel initializer. I'm going to replace that. So you can see over here, right? Now I have the message saying as Keras 2 API. Based on the Keras 2 API, syntax has been updated now. Okay. And finally, you will be seeing that my input dimensions will be same. Input dimension is almost same. Only the thing that got changed is 2 parameters. One is units and one is kernel initializer. So let me just make these changes in my other hidden layers also. And I'm currently using he uniform for ReLU because that works well. And remember guys, why I've given input dimensions as 11? This basically indicates that how many input features are connected to this hidden layer. So based on my, if I see my X train, I can see that total number of columns are 11. So because of that, I've given my input dimension as 11. So in short, this creates a neural network wherein your first layer is basically having 11 input neurons, right? Like this. Your second layer is basically having 6 hidden neurons. Okay, so it is, sorry, it is 7. So okay, it is 6. Sorry. So this 3 and this 3. Now similarly, I'll add again 6 hidden neurons in my next layer. Why I'm doing this? How I'm coming to know that I have to add 6? I have just put up 6 right now. Later, by using hyper optimization technique, I'll show you how we can come to exact solution that how many hidden neurons I have to use, how many hidden layers I have to use. So that is what I have done in this particular first step. In the second step, I'm again adding a hidden layer with 6 hidden neurons. Okay, so I'll just execute it. First of all, let me just execute it from scratch, starting. Okay, so here again, I have used my kernel initializer as he uniform and my activation function is ReLU. Guys, if you don't know about this weight initialization parameter, please look to my videos of weight initialization in deep learning playlist. I've already explained about it. And finally, we have also discussed about sigmoid activation function, right? And my last layer will be a 1 dimension. So basically, I need only 1 hidden neuron because this is a binary classification. And based on that, I will be able to predict whether if it is greater than 0.5, I'll say that the answer will be 1. Okay. For this, the answer will basically be 1. Okay. So for that only, I'm using sigmoid activation function. Always remember, guys, all your hidden layers should be having ReLU or leaky ReLU because those are the most famous activation function. And ReLU prevents, vanishing gradient problem issues as compared to the sigmoid. So final layer, I'm going to add one neuron. So here I'll execute it. Now, if I go and see my classifier dot summary, I see this. You can see that it will show me the complete how many layers I basically have, how many number of output neurons I basically have, everything it will show. And total number of parameters basically indicate that how many weights and bias parameter are there. You can also calculate it by seeing that how many neurons are basically there and how many number of weights it will get created. You can calculate it manually. After this, we will be compiling and I'll be providing my what kind of optimizer I'm going to use, what kind of loss function I'm going to use, and what is the metrics that I'm looking onto. Now, always remember, guys, in the first epoch, right, you know that the weights and the inputs gets multiplied, and similarly, it happens in each and every layer after the activation function is applied. Okay. Now, final output, when you get it, then you derive your loss function and you create an optimizer which will reduce your loss function, right? Now, here I have discussed about different types of optimizers, right? We discussed about stochastic gradient descent, we discussed about ADA delta, we discussed about ADA grad, we discussed about RMS prop, we discussed about Adam. So currently Adam is the best and the most popular one. So what you can do is that you can write optimizer is equal to Adam. Loss, we will basically be using binary underscore cross entropy. Now always remember, guys, whenever your output is either 0 or 1, you should prefer using binary underscore cross entropy. If your output has multiple categories, then you should basically use categorical cross entropy. And this information is basically given in the Keras documentation also. And the metrics that I'm going to use is accuracy. So let me just compile this. Basically, I'm setting up my optimizer. And finally, I'll do the fit where I'll say that take my X train, Y train, validation split. I'm also going to take validation split so that I can test my data set separately, test this model separately for the, for the test data set. And then I will set my batch size to 10. I hope everybody knows why we use batch size. Batch size is specifically used so that the computation power becomes less, more amount of records you don't have to load at just one time. Your RAM will be pretty much free and you'll be able to run this program in your laptop only. And then this is basically your number of epochs. Now let me just execute this. Okay, let me just execute this. Now, after you seeing this, you will be seeing that your epoch will be starting, and total number of epochs that I'm going to run is 100. Now you can see over here, the accuracy is increasing. It has come to 86 by using the right kind of kernel initializer, which is your weight initializer and other parameters. It is going to take some time, approximately 5 minutes or 3 to 4 minutes. Till then, I'm just going to pause this video. I'm just going to fast forward it. Till then, I'll just pause it and I'll continue once the training has got over. So 98 epochs has got completed and this is my 100 epoch. Now after 100 epoch, you can see that your accuracy, training accuracy is 86%. Your validation accuracy is also somewhere around 85%, guys. So remember, by just selecting the right kind of initializer and by just using a simple neural network, you are able to get 86%. But just imagine if you don't select these parameters perfectly, which I have already tried. You just try to select some other parameters for kernel initializer, right? Suppose kernel initializer, you can also consider uniform. Okay. At that time, I saw that the accuracy had decreased to 82%, right? So this after training, you can see that I have better got an accuracy of somewhere around 86%. Now what I'll do is that I'll try to test it for my training data, sorry, test data. Now what I'll do, I'll just say classify.predict on X test. And finally, I'll say whichever is greater than 0.5, consider it as true or false. And then I'll be using my confusion matrix. Confusion matrix for this, I'll be importing from the confusion matrix library. And this is how my confusion matrix looks like. If I go and see my accuracy score for the test data, and this is my score. Let me see my score over here. So it is somewhere around 85%, guys. See this, the training accuracy is almost same, the validation accuracy is almost same, and your final accuracy of your test data is also almost same. This is a perfect way of doing it. Now what I will do is that I will try to increase the number of units. Let's see, if I try to increase the number of units, that is my number of hidden neurons. I'll also try to increase one more layer. Let's just increase one more layer. I'll say that adding the third hidden layer. Okay, and here okay, let me just take it as 15 hidden neurons. Okay, so here also I'm going to use activation function. Now instead of he uniform, I'll use he normal. This is also another weight initialization that works well with ReLU. Works well with ReLU. From where I'm getting this information, guys, I already showed you from the Keras documentation. And you can basically try different things. So I will execute everything till here, from here. So from here I'm going to execute it again. Again, it will take some time for execution. I'll just pause the video and I'll just come back when the epoch is somewhere around 90th epoch. So 80 epoch has been completed. Another 16 more epochs. See how quickly the things are happening, and you can observe something that accuracy is also increasing, right? When I use the previous combination, and again, this is from research, guys. They have told that use this particular mechanism wherein if you're using ReLU, use this kind of initializer, it will work well. So they have also done a lot of permutation and combination. But what I observed, the validation accuracy is decreased from the previous time. But let us see for the test data, what accuracy it brings. So currently, my previous model score was 85. Somewhere around this can be considered 86%. Now what I'll do, I will just execute this all things. Now, yes, it is almost similar. It is basically having 85%. Now, if you want to still more increase the accuracy, guys, I'm telling you, don't do it as an overfitting. Don't create more multiple layers. Let us just try to add dropout. Now, if I create a deep neural network, what I can do is that I can basically create a dropout layer also. So let me just write it out. Classifier dot add, and I hope everybody knows what is dropout. If you have a deep neural network, you can basically apply dropout with some dropout ratio like 0.3. I'll just take it randomly, but later on I'll try to find out all these values by using hyperparameter optimization. See, your code is also ready. I'm just working on it and I'll show it to you how to do it. Okay. So, but just understand over here right now, I'll just apply dropout everywhere. So suppose I'll apply 0.4 here, and the number of neurons are a little bit less. Here I'll just apply 0.2. Okay. Now, after applying dropout, let's see whether this will increase, because I just have 10,000 records, guys. But in most of the scenario, you'll be getting million of records to work with. So let's again compile from the starting and do the fit. Okay. What I'm going to do is that I'm going to execute from here, and I'll execute till here. All the combinations you should basically try. I should try to see whether they are improving things or not. So has it started? Yes, it has started. Again, it will take another 3 minutes. So I'm just going to pause the video and come back in the 90th iteration. So 85 epoch is about to complete. Yes, 86. Now 10 more epochs. But what we observe here, the accuracy has been still in 82%. By using the previous techniques, by using without dropout, at that time we were able to get 86%. But don't just consider, guys, whether this accuracy, if it is coming down, that does not mean that it is having a bad accuracy. See, that scenario may be leading to overfitting and underfitting. Dropout also plays a very good role. If you don't know about dropout, I've already created a video in my deep learning playlist, and you'll understand the importance of dropout by seeing that video. Let me just go and predict it for the test data again. Now you can see my test score has just come down by 1%. Then I think you should try to apply dropout for very, very deep neural network, because that will give you the right type of combination for testing the data itself. So this was all about the artificial neural network creating from scratch. This two code basically helps you to see how your validation accuracy was going down, coming up in the graph wise. The main thing is, guys, that we need to know how to initialize this. How many number of layers is suitable for my neural network? How many number of hidden neurons should I take? Which activation function is good, right? So we should try to do this combination by using a hyperparameter optimization technique. And that will what will be in my next video. See, I've already started creating this, the hyperparameter optimization file, taking the same example. And here I will try with different things, different layers. I'll just make different layers, different batch size, different epochs. And then I'll come back in the next video. I hope you are liking this video. This is how a neural network is basically created from scratch. Now you can see that you're basically able to get 86%, which is a very good accuracy. I'll tell you, just on 10,000 records. Because if you increase this particular records to 1 million, I can definitely make the accuracy more than 90%. And make sure you know the various combination of kernel initialization and the activation function. So please do subscribe to the channel, guys, if you have not already subscribed. Thank you one and all for the wonderful support. My channel is growing. This is all because of you all. I will definitely assure that I'll put more interesting content as I go ahead. Thank you one and all. I'll see you all in the next video. God bless you all. Thank you.